Hi there. You've all shown up for your learning. That's so exciting. So I do appreciate all the effort that you put into your studies and the attention that you give to lectures like these. So let's go. Yesterday, we looked at multiplying and dividing rational expressions. And today we're going to look at adding and subtracting some rational expressions. And if you want to see more examples when I finish the examples that are in your package today, I'll open up some delta math and go through some delta math before your very eyes. Okay, there's some good problems in there as well. So one thing that we want to remember with fractions is whenever we're adding and subtracting them, we have to create that lowest common denominator. Of course, over here, what's the lowest common denominator for these two fractions? 10. Yeah, it's 2 times 5. 2 times 5 gives us the lowest common denominator equals 10. So that would look like this. You multiply this one by 5 over 5, and you multiply this one by 2 over 2, multiply by 2, multiply by 2. And then you would have 15 plus 8 over 10. So this is 23 tenths. And we're pretty comfortable with that idea. Over here, we also need to create a lowest common denominator. What is the lowest common denominator here? Malcolm? Nope. Nope. We're actually going to just take these and multiply them.
Can you multiply x plus 1 and then multiply the other one by x plus 4, so it's going to be x plus 1 times x minus 4 and x plus 1 over x minus 4, and then you can drop the numerator?
Yeah, that's right. So what we do here is we're going to have the lowest common denominator being x plus 1. Oops, I usually write my x's that way. X plus 1 multiplied by x minus 4. So it's the same principle that we had here, where we just multiply the two denominators by one another. However, with fractions, we don't have to create the biggest possible denominator. If they already share factors, we don't need to multiply those factors in extra as well. And you're going to see that throughout the problems. But when we do this, when we multiply this bottom one by x minus 4, we're going to multiply top also by x minus 4 and bottom by x minus 4. And then this one's going to be top by x minus 1 and top by x minus 1 and bottom by x minus 1. Multiply top and bottom by the same thing. You're multiplying by 1, and that will give you your common denominator. Did I write minus 1? I did. My goodness. Yeah, this will be positive. There. Let's keep going. So, our steps for solving these types of problems is first, factor your numerators and factor your denominators. That's the same with a multiplication or division problem. Ella?
What was the answer to the last one?
I'm going to need some blank paper to do that on. Let's see. So 8 over x plus 1 times 5 over x minus 4. So let's write it out. I kind of regret that there's not enough space on there to do it. X plus 1 minus, right? Was it minus? 5 over x minus 4. Yeah. So we bracket these. You're going to multiply here x minus 4 on the bottom and on the top. You're going to multiply here x plus 1 on top and bottom. Notice that creates a common denominator. We're going to have our denominator as x minus 4 multiplied by x plus 1. You can expand and simplify that with FOIL, but I would encourage you to leave it in factored form in case, after doing your addition and subtraction, you see another factor that could cancel. So that saves you from refactoring it again later. And then we'll have 8x minus 32. That's the result of 8 times negative 4 and 8 times x. And then we'll have minus 5x. I'm going to put this in brackets, minus 5x plus 5. Okay, and now let's bring that down. This is equal to 3x minus 37. Unfortunately, there's no common factor there, over x minus 4, x plus 1. And then we could do the 0, 1 test at this point. So the 0, 1 test at 0, I'm just going to do the 0 test. When x is 0, this fraction would be equal to negative 37 over minus 4. So it's 37 over 4, positive, at 0. If I check up here, when x is 0, it's 8 minus 5 over negative 4. Yeah, that sort of feels like it would be a positive number. 8 minus 5 over 4, that's 32 minus 5 over 4. That's indeed what we had. Wait, no, it's plus 5. It's 37 over 4. Yeah. Allison? So pass the 0 test.
Why don't you foil the bottom of it?
Oh, sure, I can foil the bottom of it. Then it would be equal to 3x minus 37 over x squared minus 3x minus 4. And then that would be that would be the fully simplified version. Cool. Okay, let's keep going with some of these examples because we want to get into some meatier ones. After you've factored your numerators and denominators, then you're going to find your lowest common denominator. Once you've done that, you're ready to state the limitations, the restrictions on your denominator. Write each expression with the lowest common denominator by multiplying top and bottom by the same factor. And then simplify by expanding and simplifying the numerators and stating restrictions. And it says here you don't need to expand the denominator. Sure. Okay, fine. I think Delta Math won't mind if you don't expand your denominators. But you will need to expand and simplify your numerators so that you get everything into standard form. And then you can add your ax squareds with your ax squareds and add your bx's with your bx's and add your c's with your c's. So that's how you would collect it on top. You do need to expand those. So let's try this one. Okay, so first step, factor. This is equal to x plus 3 over, I forget, how does that factor, Mr. Jennings? How does that denominator factor? Plus 2x minus 2. Good. So that's the difference of squares. We have x plus 2 times x minus 2. And then I look at this one and I say, ooh, you're jealous. This fraction over here is jealous of the x minus 2 factor that one has. So just like any good daycare provider, I am going to give all the toys to both denominators. They all need identical toys or else they get jealous of each other. This one's not jealous, so I don't need to add anything to that one. So now we multiply this through. So, and it also said we should state our restrictions at this point because we're not going to get any more restrictions by continuing this problem. So we can already say that our restrictions are x is not equal to what two values? Plus or minus 2. Plus or minus 2. We can't have minus 2. We can't have plus 2. So disallow those two values. And carry on. So now let's go. We have, this is equal to, this is still x plus 3 on top over here. I'm going to draw this over a single denominator, and I'm going to say plus the stuff that's in the brackets from the other side. In that bracket, I'm going to put the result of this multiplication here. And on the bottom, I have the denominator, the now common denominator, x plus 2 multiplied by x minus 2. Because both toddlers got the same toys, they can now play together and share the same denominator. Okay, x plus 1 times x minus 2. Let's FOIL it right here so that we can kind of have a minimum of rough work right there. X times x gives us x squared. X times negative 2 gives us negative 2x. 1 times x gives us plus x. So I had negative 2x plus x. I'm just going to have negative 1x. See, I'm skipping a step there for the sake of tidiness. Is that okay that I skip that step? Yeah, okay, I'm getting some nodding, so that's good. And then I have 1 times minus 2, so that's minus 2, okay? And now I'm ready to see how I can add my bx to my bx and my 3 to my 2 and stuff, and now I can simplify this. This is equal to, well, I'm going to first write my x squared terms, because I'm in the habit of writing ax squared plus bx plus c. I'm not in the habit of writing bx plus ax squared plus c. I'm going to move that to the front for standard form. Okay, so I have 1x squared, so I first collect those. x squared. And then I see I have x minus x. So I have 0x. And then I have 3 minus 2. So I have plus 1, x squared plus 1 over x. I could write this as x squared minus 4. It said before, don't simplify your denominators, but here it saves me some pen strokes, so I did that. Just multiplying this out. Or remembering that we had factored that before and that was what it came from. Allison?
I don't understand why you did any orange like these X marks.
Oh, so there I'm multiplying top and bottom by the same factor. It's the same thing that we would do over there. See where we had 13 over 21 and we multiply it by 8 over 8? Because 8 over 8 is just 1. It doesn't change the nature of 13 over 21 when it becomes 104 over 168. It's still the same thing. But by adding those factors to it, it creates that common denominator. Now we have factors that are functions of x. And so we're going to be multiplying by binomial factors or even trinomial factors to create common denominators for our problems. Anna? Yeah, sure. So carry on, keep going. Yeah, another example. Aha. Okay, so let's simplify this one. First step, factor everything. 5x minus 1 won't factor. No common factors there. X squared minus 3x plus 2. You do the factoring, I do the writing. Negative 2, negative 1 are my numbers, so they go in with the brackets here, x minus 1, x minus 2. Cool. And then this one here, 2x minus 4, does that factor? Yes. Two x minus 2. Okay. So now we have to go ahead and create our common denominator. So I'm going to get out my common denominator pen. I notice that this fraction over here, this one, is jealous of this x minus 1 factor. It wants it too. It wants to play with that factor. So we're going to multiply there top and bottom by x minus 1. Put it in brackets so that you remember to distribute this 3. And then down here, x minus 1. Okay? That's multiplying by 1, so I'm not changing the nature of that thing. Unless x is 1, in which case that would create a contradiction. But we already have that limitation on the domain. This fraction here is jealous of this factor 2. So I need to multiply this top and bottom by 2. Okay, so now see that we've created that common denominator of 2 multiplied by x minus 1 multiplied by x minus 2. So let's now state our restrictions. X is not equal to what two values? Plus 1 and 2, yes, that's right. So these are our restrictions here. And then let's work everything out. 2 times 5x minus 1. Put a bracket here so that you remember to distribute this 2 to all the terms there. So that will be 10x minus 2 plus, and then we could put this in brackets here, distribute this 3 into that bracket, because we want to multiply the top times the top. So that's 3 times x minus 1, which will be 3x minus 3. Okay. All divided by our new fancy-dancy common denominator, 2 x minus 1, x minus 2. Dun, 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 dun. Collect your like terms on top. This will be equal to 13x minus 5. Nothing to factor there, unfortunately. Over 2 multiplied by x minus 1, x minus 2. And that's the simplified form of this junk. Yuck. Let's write that a little more beautifully, Mr. Jennings. There. Carry on. Okay, let's go. Do another one. Let's simplify this one. Oh, we got y's here. Great. Okay, so 4 minus 5 all over fancy dancy trinomials. So let's say this is equal to, we're still going to have 4 on the top here. We're going to have 5 on the top there. I'm going to move that equal sign in just a moment. Copy the architecture of the problem. This is equal to this stuff. And let's see, let's factor our bottoms and our tops. Y squared plus 5y plus 6. Yeah, y plus multiplies to 6 adds to 5. 2 and 3. Y plus 2 multiplied by y plus 3 minus 5 over y minus 12. Multiplies to negative 12, adds to negative 1. Yeah, and which flavors of 4s and 3s? Yeah, at y minus 4, y plus 3. Good. And now, let's see, what do we need to give these feuding toddlers so that they do not fight over the toys? Well, this one lacks a y minus 4, so let's give it y minus 4, top and bottom. And I see that that toddler is now satisfied. It has all the toys that this toddler has. And then this toddler is jealous of the y plus 2 factor. So let's also multiply in a y plus 2 factor there. And here, y plus 2. Okay. And now, state your restrictions. What are the restrictions on our domain here? We've got 3. Y is not equal to negative 3, negative 2, and 4, positive 4. Good. So there's our restrictions. Cool. Now, bring in another line. We're going to leave our common denominator there, unsimplified, no problem. And I'll write it in ascending order of the zeros, I guess. So y plus 3, y plus 2, y minus 4. Notice that if you multiply that out and simplify it, it will create a cubic. You'll have a y cubed term. And you're going to be exploring those a lot more next year. Polynomials that are cubics. And then let's do 4 times negative 4 times y. So we're going to distribute this 4 into that bracket. So we'll have 4y minus 16. And then we're going to distribute this 5 into that bracket, minus 5y minus 10, because it's minus both of them. I could have put that in brackets and said 5y plus 10, and then it's minus both of them. So however you like to do that, do it your way. Just don't make a sign error, because if you make a sign error, all that hard work, and then it suddenly starts failing the 0-1 test, and you're like, why? Why is this failing the 0-1 test? Because you made a sign error. I haven't made a sign error here yet, I don't think. So 4y minus 5y will give us negative y, and negative 16 minus 10 is negative 26, all over that funky denominator. Y plus 3 times y plus 2 times y minus 4. And I could factor the top. I could say that's minus y plus 26. But y plus 26 doesn't cancel anything on the bottom anyway, so hey, there we go. This is fine. Leave it like that. Don't need to factor the top. Okay, carry on. Yeah, let's carry on. Yeah. Another example. Well, let's go ahead and factor it. All right, so here again, we're going to have some nastier factoring. So let's do the nasty factoring on the side. For this one here, I'm going to use blue, and I want to first win this X game. 30 multiplies to and adds to negative 17. What multiplies to positive 30 and adds to negative 17? Yeah, negative 15, negative 2. Good. So that's that negative 15, negative 2 is what I'm going to use for 6x squared minus 15x minus, let's do minus 2x minus 15x. Let's do 2 there. Minus 2x minus 15x plus 5. All right? So we decompose that middle term with these two numbers that came from, we take 7, multiply it by 5, and put that number there, 30. And then we go ahead and find the numbers negative 15, negative 2 to decompose that number negative 17. Then we common factor both pieces. So this piece here, common factors out at 2x multiplied by 3x minus 1. That's what happens when I divide both of those by the common factor, 2x. And these have common factor negative 5. So then we will have negative 5 coming out, and that will give me 3x minus 1. Then the final factorization of this is 3x minus 1 multiplied by 2x minus 5. People comfortable with this method for decomposing trinomials when a is not 1? Ella?
You have like 30 on the top.
Mm-hmm. Yeah. And that comes from multiplying a times c. It's the same thing we do when a is 1, and we look at like finding that number that multiplies to c and adds to b, because then a times c is just c, because a was 1. But when a is non-1, I like to play that x game and then decompose the middle term and then common factor. I take shortcuts when a is 1. Ali?
Do you not do anything, like, do you not bring in the 2x with the 3x, like multiply that, and then multiply the negative 1 by the 2?
The reason I common factored this piece and that piece to take out the biggest common factor in the first two terms and the next two terms was so that I could separate the 2x and the minus 5 from this common binomial factor. Notice that same binomial showed up in two places. Then we factor out that common binomial factor from both places so that it ends up in this form. And that's the closest to factored form that we're going to get.
Why'd you put the 2x and negative 5 together?
Oh, because this came up yesterday in the afternoon. So people found this demonstration useful. I wanted to share this idea. Let's say I've got something like 5a minus 3a. And we know that that's 2a. But I could also common factor this if I want. I can common factor out a and have 5 minus 3. And so that a comes out. If I multiply this back in, you'll see I'd recreate that. So that's a monomial factor being factored out. Okay. Same idea. If I have 3 x minus 1s minus 2 x minus 1s, then I can factor out this common factor in the same way a is coming out. X minus 1 will come out of both terms, and it will be 3 minus 2. If we look at it at this level, I have 3 of something minus 2 of something, so I should just have 1 something left over, just x minus 1. Here I have x minus 1 multiplied by 1, so it's the same thing. And so that's those factors coming out. The difference that we see here is that we have a situation where it's not 3 minus 2, but they're not common factors anymore. It's 3x minus 2 times these things. And so then we would end up with something that looks like that. This factors out of both the same way the a is factoring out of both. But now we're factoring out a binomial instead of a monomial, a two-term expression instead of a one-term expression. Make sense? Hope so. So that's one of them factored. Let's keep going. Okay, so I'm going to take the liberty of clearing some space so that I can factor the next one. But I'm going to leave that factored form down there. That was grody anyway. All right. So now let's go. 2x squared minus 11x plus 15. Let's factor it in another color. So we're going to factor this one in orange. First, I'm going to multiply to 30 and add to negative 11. What two numbers multiply to positive 30, add to negative 11? Yeah, negative 6 and negative 5, yeah. Good. So that's how we're going to decompose this middle term. I'm going to group the minus 5 with the 15 because I can see they share factors, and group the minus 6 with the 2 because they share factors. So this becomes 2x squared minus 6x minus 5x plus 15. Factor by common fact by factoring by grouping. This is factoring by grouping, this is called. 2x is the common factor there. And it's going to multiply by x minus 3 once I divide those both by 2x. And then minus 5 is my common factor over here. I could have taken out positive 5, but then I would have had to take out another negative 1 because I would have ended up with negative x plus 3. And I don't want that. I want x minus 3 to be my common binomial factor. And then I rewrite in its fully factored form, x minus 3 multiplied by 2x minus 5. All the gross factoring done. Oh, it's not gross. It's a fun mental exercise. This is a fun mental exercise. Say it to yourself. Repeat after me. It's a fun mental exercise. All right, so now let's go ahead and rewrite this in fully factored rational form. Here we go. We are going to have a 4x minus 7 minus 3x plus 4 over, and we're going to put these in here, 3x minus 1 multiplied by 2x minus 5, and then multiplied by over here, x minus 3 multiplied by 2x minus 5. Okay, and then we checked for jealousy of the toddler fraction factors. And we notice that our first fraction lacks an x minus 3 factor, and that won't do. They simply must have the same toys as the other one. So we give it that factor top and bottom. And then we notice that the second one, they already share the 2x minus 5 factor. No need to give another 2x minus 5 to each child. However, if one of them had two 2x minus 5 factors, like it was squared, the other one would also want 2. We need to have fairness in the world of toddler fractions. Okay? Fairness is an idea that only exists in your mind or in multiplying fractions here. So we see that this fraction here is lacking a 3x minus 1 factor. So 3x minus 1 goes in there, and top 3x minus 1. It helps at this point to remember that these things are in brackets. So when we distribute these in, we have to use FOIL. Let's go. So we have the same denominator now. It is x minus 3 multiplied by 3x minus 1 multiplied by 2x minus 5. Done. Common denominator. And then let's do the first FOILation here. X times 4x gives me 4x squared. X times negative 7 gives me negative 7x. Negative 3 times 4 gives me negative 12x. Ooh, this is going to be tight. And negative 3 times negative 7 gives me positive 21. Minus all this stuff in the brackets. Ooh, 3x times 3x gives me 9x squared. 3x times negative 1 gives me minus 3x. 4 times 3x gives me plus 12x. And 4 times negative 1 gives me minus 4. Done. Fit it all in. But my plus over there is kind of gross, so I'm going to fix that. Ah, I lost an x as well. 3x plus. There, that's much better. I'll zoom in. I can write better when I'm zoomed here. Ooh, that's better, eh? Ooh. Okay, and now let's get a nice fine pen for doing the rest. Okay, let's collect first our x squared terms. And this is a habit that you can do when you're collecting terms, and you know you have ax squareds, you know you have bx's, and you know you have c's. So let's collect first the ax squareds. How many do we have? What flavor of 5 of them? Negative 5x squared. This is equal to negative 5x squared because we have 4x squared minus. This minus distributes to all those things in there. So no anything inside that brackets, flip the sign when you're incorporating it. Let's gather our x squared, our x's, our linear x terms. Negative 7, negative 12 gives me negative 19. Minus 3, I'm now to negative 16 because I'm adding 3. And then I'm minus 12. So I'm at negative 28. Negative 5x squared minus 28x. I collected 4 terms in one go there. Is that okay? People follow? Okay, good. All right. And then plus 21 minus 4 is plus 25. A quick look at that. Can I multiply to negative 125 and add to negative 28? No, can't do it. Because it's, wait. No, can't. Cannot be done. So that does not factor. I don't believe. So that's done. Over x minus 3, 3x minus 1, 2x minus 5. What are we forgetting, everyone? Allie?
I just have a question. Can you do how you got the negative 28 incidence? I got negative 10.
Okay. So negative 7, negative 12. We got negative 19 x minus 3, so that's plus 3x, and minus positive 12, so it's minus 12 x. So then we put those together. Yeah, and I'm genuinely checking here because I might make errors there, and I didn't make an error. Okay, so we're forgetting one step in this problem. What step do we forget? X cannot be what? There's one that's an integer, and the other 2's are fractions. So x cannot be positive 3. X cannot be 3. And what are the fractions that it can't be? 3x minus 1 can't be 0. So x can't be 1/3. Right, good. So either you did your mental math in your head or you just looked at it and said, what do I need to multiply 3 by to get positive 1? Well, that'd be 1/3. So good ways to do that. So that's 1/3. And then let's say we can't do this one in our head. 2x minus 5. So this is what you do. You write out an equation. 2x minus 5 is equal to 0. And notice it's never equal to 0. We're just doing this as rough work to find out what x can't be. And then you add 5 to both sides, so you get 2x equals 5. And then you divide by 2. And so then you find that x can't be 2.5. X can't be 5 halves. So x can't be a 3, 1/3, or 5. I almost wrote 2/5. 5 halves. And there, that's done. Cool. So go ahead and get some practice. I don't think people need to see any more examples. It's been a long lesson. So I thank you very much for hanging with me there. And any questions, hit me up by email if your team Learn at Home. Otherwise, stay frosty, folks.